So, let's talk about problem number 1. This, by the way, is a good learning environment. People are like confused and dialoguing. This is the sign of like learning happening. So, problem number 1. Let's talk about the reaction. Mattel, what are our reactants? N2 plus H2. And what are they making? And H3. There is sometimes some confusion about ammonia versus ammonium. This is ammonia. It is NH3. Ammonium is NH4. So that sometimes is a problem that leads people astray in this. Okay. Step 2, we have to balance. Mallory, how many nitrogens do I have here on my reactant side? How many do I have on the product side? So what do I have to do to ammonia? I can put a 2 in front. How many hydrogens does that now give me, Mallory? So what do I have to do on the reactant side? I put a 3 in front of H2. And then what do I have to do? Pound my chest to people do like this. Okay, so people know that I successfully found a chemical reaction. Obviously, that's the next step. Okay. Nathan, how many, what information should I write down? What am I starting with? Okay, how about you read the problem? What information do they give us to start in that problem? That's what we have to start. 6 moles of hydrogen. And now it's stoichiometry time. Okay, so I'm going to make a stoichiometric ratio. If nothing else, do that step. Okay, like write down the stuff they give you and make a stoichiometric ratio. Elliot, what chemical am I going to put down below? What chemical goes in the denominator? Hydrogen. The one they gave me, I put in the denominator. What chemical are they asking me about, Leo Favo, in this problem? Ammonia. So I'm going to put that in the numerator. Smiley nodding throughout the land.
So the one they give you always goes in the bottom?
Yep. The one you have information about goes in the bottom. The one you're solving for goes in the top. Bridget, what are my coefficients from the balanced chemical equation? 2 and 3. Carly, what is 6 times 2/3? 4 what's of what? 4 moles of ammonia is the right answer to problem number 1. There's some joyful celebrations out there in the world. We've gotten through problem 1. Carlos, do you have this homework due? So what should you do when you come in? What should you do if you don't have the homework? Ask Dave. Hey Dave, can I get a copy of the homework? And you know what I'm going to say? Sure, dude. Here we go. All right. Other questions on the work of the home?
Every other question.
Oh, come on.
No,
5 A and B.
Okay.
3 A, B, and C. No, actually 3 B and C.
5 I'm going to do briefly because the balance in that chemical equation is a little bit weird because people don't see the little subscript on the sulfur, and that throws some people off in other blocks. If I have 8 Fe plus 8 subscript S subscript 8 makes 8 FeS. And so some people don't see that, and that's why people get different answers on that. So let's go ahead and do some stuff. What mass of iron is needed to react with 16.0 grams of sulfur? Elsa, what am I going to do first when they give me grams?
5.
Almost. You got the pounding right, but you didn't have quite the right thing. Divide by what? Yeah, let's do it together. Divide by grams per mole. Okay, so we'll get the grams per mole for S8. Sulfur weighs 32. 32 times 8 is, of course, 256, as every elementary school student learns. Just kidding. I've done this problem 3 times, so I have to know this fact. So we are taking 16.0 and dividing it by 256 grams per mole. And returning to our friend Kaya, who's merrily punching buttons on her calculator and coming up with a festive answer, which is correct. 0.0625 moles of S8. And now MK is excited to do some stoichiometry. Okay, so we're going to turn that into what? What do they ask us for in the problem, MK? The mass of iron. So what chemical is going to go on the top? Iron. What chemical is going to go on the bottom? Because that's what I have info about. And what are the coefficients? Elizabeth, who was not here for this but still is a smart kid and can figure this out. What is the coefficient on iron in the balanced chemical equation? 8. Okay, and what is the coefficient on sulfur in the balanced chemical equation? 1. Ta-da! Go ahead. So now Ella is taking her calculator and she's multiplying 0.0625 times 8 over 1, and she gets 0.500 moles of iron. And Julia has one last step to do for the team. We want to turn that moles of iron into a mass of iron, because they asked us about what mass of iron is needed. So what am I going to do here?
You multiply it by grams per mole.
And what is the grams per mole for iron?
55.845.
I'm not going to be that much of a stickler. I'm just going to say 55.85. We can leave that last sig fig off. And what, I forget where I am now. I think I'm going all the way around the horn. Mallory, what do we get when we multiply 0.5 times 55 with 85? I disagree. If it's 0.5, that's basically multiplying it by 1/2. It should get smaller. 27.9 grams sounds reasonable to me. Mom nodding throughout the land. Carlos, you might as well write that down so we just went over it on the board. Problem 5B, 5A, sorry. Let's go.
Wait, so for the first, so when you're dividing by grams per mole, do you want to divide by like 8 times the sulfur because it's S6?
Yes. You multiply by the subscript. You do not multiply by the coefficients in the grams per mole step. You only multiply by the subscripts in the grams per mole step.
Okay, because it was different at the end.
Coefficients show up here in the heart of the problem that is stoichiometry. That's when we use the coefficients. The subscripts come into it when we do the grams per mole stuff. Talk to the person next to you for a minute now that we've done like a couple of these problems on the board and maybe we've cleared up some of these confusions. Take another minute and talk about some chemistry. Go.
Oh, we just did it. We got 0.5 moles and then we multiplied by 55.85. Oh, that's oh wait, no, that's not. So 5 that would be.
I see where you're going for. Leo is starting from here. He's using that and he's putting iron on the bottom and FES on the top.
8 F. So for every F,
So not.
so
FE.
for every 8 FES, there's
Oh,
also
you
iron. Then you would do 0.5. This is half of a mole. And then you do.
So it's 0.5. So it's 0.5 grams.
0.5 what?
That's mole. These are the grams. And
So it should be just 1/2 of a mole times whatever. Why? Because I didn't write it 1/2. Oh, you got. I only answered. Wait, did you like say
You just add them.
where's it possible that's less?
You just add
Oh,
the
this is 8.
and the ammu.
Yeah, I did it. Half the mold iron times 8 over 8.
See, exactly. Because sometimes
Equals
It's 87.9. You just have to add them.
Somebody pick one of 2, 3, or 4. Which other one do you want me to do? 4? Alright. Problem 4. Dinitrogen monoxide and water combine to make ammonium nitrate. That is the chemical reaction for number 4. We need to balance this. Mathilde, what do I have to do to balance this? How many nitrogens do I have here? How many do I have here? So that's balanced. Nice. How many hydrogens do I have here? How many do I have here? So what do I need to do? How many oxygens does that give me from this molecule? And from this molecule? For grand total of? And how many do I have over here? So it's balanced. All right, Nathan. If the reaction produces 60 grams of ammonium nitrate, how many moles were produced? What am I going to do for that? If I want to say it in a super boring way, I would say that. What else would I do? Yeah, that's a lot more fun, isn't it? So we now have to figure out the grams per mole of ammonium nitrate. Elliot, what is the grams per mole of nitrogen? Well, look at your friend, the periodic table. Thankfully, Dimitri Mendeleev made a beautiful table. It's also like organized in columns. Say again? Nope, nitrogen. Nathan's trying to give you like the whole answer. He doesn't trust you. He doesn't believe that you can do this. He thinks that like helping you right now is gonna like be better for you. You can try to spotlight, but really you can just do it. What's find nitrogen on the periodic table? And what's it? Thanks, dog. That's enough. Let's just say 14. Okay, plus 4 hydrogens, plus another nitrogen, plus 3 times oxygen. And then we put all that together, Leo Falco, what is the weight of ammonium nitrate? 60? 80. All right, so now I'm going to divide by grams per mole. And I used to be able to pound the smart board, but now that it's like smart like TV, I'm really worried about doing that. So we divide by grams per mole. Bridget, what's 60 divided by 80? 0.75 moles of ammonium nitrate. How many moles of dinitrogen monoxide were consumed? We got to do some stoic to figure this out. I'm going to take that number from part B, 0.75 moles NH4NO3, and turn to my friend Carly for some help with my stoichiometry. Carly, what chemical am I going to put in the denominator? Ammonium nitrate. NH4NO3. What chemical am I going to put in the numerator, Carly? Dihydrogen monoxide, N2O. Carlos, what's the coefficient on N2O? Nope, the coefficient. There's no coefficient. We assume it has a coefficient of 1. What's the coefficient on this? 1. What's 0.75 times 1 over 1? 0.75. So you have 0.75 moles of N2O. Yes.
I got the equation wrong. I checked online to make sure it's the right way I balanced it, but for the ammonium nitrate, I switched because it's
NH4 is a plus 1 ion,
Oh.
and nitrate is a minus 1 ion, so it's just
I have no idea what it is.
1 to 1. That's probably got to memorize the polyatomic ions back in November in order to be able to like do this stuff here. chemistry like builds in this way. All right. We're going to turn that into a volume. Elsa, what am I going to do to turn moles into volume?
Multiply by 22.4.
Multiply that by 22.4 liters per mole. I'll let you guys do that. That's punch buttons on a calculator. I'll ask Kaya a more interesting question. Kaya, we want to know the molecules of water that were needed. So I'm going to start from this. Let's see, I don't really have room on here. I'm going to go to a new slide. I have 0.75 moles of ammonium nitrate. And now I want water. So Kaya, it's story time. What is going to go in the numerator? What's going to go in the denominator? The thing I have, which in this case is NH4NO3. MK, what are my coefficients?
2 on H2O and 1 on
Nitrate. Elizabeth is reaching for a calculator. 0.75 times 2 over 1 equals 1.5 moles of water. And now Ella wants to turn that into a molecules. How do I go from moles to molecules? Yeah, do. That's what I'm going to do. I'm going to multiply by 6.02 by 10 to the 23rd. And when I mean me, I mean Julia. Okay? So that's my molecules per mole. 9.03 times 10 to the 23rd molecules of water. Mic drop, there it is. Boom. We can do this stuff. Everybody's like, I can't do this stuff. You do this stuff. So Untitled, pass your homework to Nathan or Ella. Go. Take out your book of notes. Let's prepare for lunch by discussing some fairly crappy ham sandwiches.
Oh, no, I watched
You
the
can
video.
pretty much put anything in between 2 pieces of bread and call it a sandwich. Yep. This week, a guy in New Zealand and a guy in Spain figured out exactly by longitude and latitude the opposite corners of the Earth, and they simultaneously put 2 pieces of bread down to make a whole Earth sandwich. The biggest sandwich possible was made this week between New Zealand and Spain. They tried. They were like, okay, 3, 2. I mean, that might not even be a sandwich. It's not at the exact moment. I'm not sure if they then tried to eat this sandwich, but they have now made a sandwich out of the entire world. We are not going to make such a big sandwich. We're just going to talk about some regular old ham sandwiches. Hopefully by now you've taken out your notebooks and written down this chemical equation. 2 pieces of bread plus 1 piece of ham makes 1 sandwich. You can leave the word boring out of it. Sandwiches. Okay, we'll get the time set. Just write down the equation. All right, so we got this chemical equation written down. 3, 2, 1. If I have 6 pieces of bread, how many sandwiches can I actually make? 3, because I can make 1 sandwich for every 2 bread, so I can make 3 sandwiches. If I have 5 pieces of ham, how many sandwiches can I make? I can make 1 sandwich for every 1 ham, so I can make 5 sandwiches. If I have this much stuff in my kitchen, how many sandwiches am I actually going to be able to make? 3. Why? And what is that limiting factor? The bread. I'm going to run out of bread first. Limiting reactant. So this is a review of that term. We're going to call the bread the limiting reactant, or limiting reagent, it is sometimes called. It is the thing you know first, the thing that produces the lesser amount of product. Smiling, nodding. Okay, that's reasonable. Let's play the game again. If I have 16 pieces of bread and 6 pieces of ham, how many sandwiches am I actually going to be able to make? Discuss with the person next to you. Oh, come on, let me at least pick up the marker. Oh, we're smart, we figured these out already. Okay, so based on my bread, I can make 8 sandwiches. Based on my ham, I can make 6 sandwiches. How many sandwiches am I actually going to be able to make? 6. Smile and nod. Easy peasy. Lemon squeezy. All right. We're not making a bread sandwich. Nobody wants that one. And we're just leaving the bread. We'll get some peanut butter later, and tomorrow we'll make some different sandwiches. Hold on. Let's do the same thing, but with the word moles, and let's not get scared. Okay? Write down this as a chemical equation. 4 sodiums plus 1 oxygen makes 2 sodium oxides. And then below that, on separate lines, maybe even skipping a line to keep your notes nice and organized, let's write down the moles of each of these reactants that I have. Okay? So I have moles. I want to know how much of this product I'm actually going to be able to make. It's stoichiometry time. Leo Falvo, what am I going to put in the denominator for this top row? 4Na. Leo likes to show off and do the coefficient at the same time as picking the chemical, but that's the kind of, bold guy that he is. Bridget, what's going to go in the numerator? 2Na2O, which happens to have a coefficient of 2 and 4. Carly, what is 2 over 4? What does that simplify down to? What's 1/2 of 5? Instead of a lot of energy and excitement, 2.5 moles of Na2O and D. Not yet. Just getting an example problem here. Calm down. Okay. Carlos, when I do a stoichiometric ratio on the bottom, what chemical is going to go there? Not 3 moles of oxygen. It's going to be oxygen, but I'm not going to use the number there. I'm going to use the number for the balanced chemical equation, which is 1. And what am I going to put in my numerator, Elsa? 2Na2O. And Kaya, what's 3 times 2 over 1? Nope. 3 times 2. 6. MK, how many moles of product am I actually going to be able to make? Nope. Am I going to be able to make 6? Am I going to be able to make 2.5? I'm going to be able to make 2.5. I'm going to run out of sodium first. It's going to limit my amount of product that I can make. So I'm going to identify this as the predicted amount that I would actually be able to make. And I would identify this as my limiting reactant. Yo.
Does it always have to be like a whole number? Like if it's not, would you round down?
Would what have to be a whole number? The amount you can actually make? No. It can be like 2.478 or 0.006325 or 6.
Are we not supposed to do sick things?
We're not doing it here because we're just getting an example problem. Oakley dokley, same basic concept as the sandwich problem, except the word is moles instead of like bread. But totally doable, yes? All right, so how can I make this problem more interesting for you? What can I give you instead of moles? Grams. Because we know how to get from grams to moles, and we enjoy pounding on our desks. So let's go ahead and work with the person next to us and do this nice, full, rich problem. 145 grams of sodium with 36 grams of oxygen. Game on. Same base reaction. It's stoichiometry time. Actually, first it's divival, and then it's stoichiometry. To move, you can stand up and move to the middle class and to both for Parker and the universe. Nico is abandoning you. Tears are running down your cheeks. I think I'm giving the Cooperating with Your Partner award once again to Ella and Julia are actually talking to the person next to them while they work so they get the sweet tarts for a day.
So they gave us this 10 36 divided by what's this grand total? 16, right? Double that is 32, so 36 divided by 32.
I got 2.25 there. No, now we're going to. So this don't matter
The grams from all, you just use the subscripts. The stoichiometry, use the coefficient.
the coefficient.
I know, there's no- Thank you. Sorry for interrupting your question.
You do the 2 No, I did all the homework until 5, and I couldn't let me go. Oh yeah, it's great.
The artistry, yeah.
It's
You outsource all your data to Joe.
Nope.
Oh, no.
Nope. There's one kid, Alex Persada, who's in Chemist last year. He's not in chemistry this year, so he grades during B block. Joe grades and I grade. Between the three of us, it's like get a 1/3 chance to get Joe fully graded. All right. I have no idea where I am, so I'll start with my friend Leo Falvo. Leo Falvo, what am I gonna do first with this stuff here? That is, and I'm gonna wear glasses if I need glasses because that would help me get through life and stuff. All right. So we divide by grams per mole. The grams per mole of sodium is She thought it'd be easier if she held the paper and moved it around. All right, so around 23 grams per mole. And what do we get? Lawyer Bridget? We don't need to round yet. We're still dividing the problem. 6.31. Okay. Moles. You just prefer squinting. Makes it look more handsome. All right. Carly, what am I going to do down here? And what is the grams per mole? Which is? Carlos, what is 36 divided by 32 grams per mole? One point something, that's right. 1 point. 1.125 moles of O2. And now, Elsa, what time is it? That's right. It's stoichiometry time. Oh, it's some sort of chemical thing with numbers time. Okay, so Elsa, what is going to go on the bottom here? What chemical am I going to put in the bottom?
Oh, the first one?
Yep.
4Na.
4Na. And what chemical is going to go on the top?
2Na2.
2Na2O. Kaya, what's going to go in my coefficient ratio here?
On the bottom, you're gonna get 1 or 2.
Uh-huh.
And then on the top, you're gonna get 2Na2.
Bet I am. Alright. So now Mary's going to tell us what's 6.31 times 2 over 4, Mary? 3.15 moles of product. And Elizabeth, what's 1.125 times 2 over 1? 2.25 moles. So, Ella, how much product am I actually going to be able to make? 2.25. Julia, what was my limiting reactant in this situation? The oxygen was the LR. Give the person next to you a hearty high five. You got that. That is a journey. Oakley dokley. Doable. What else could I give you instead of grams? Liters. What else? Number. So, if I start with, you're welcome, 4.5 times 10 to the 24th atoms of sodium, react that with 63 liters of oxygen. What in the world is going to be the limiting reactant? What's going to slow us down this time? Game on. He's just going to try and guess this one in his head. Most of us would use calculator and paper at this juncture in our lives. He's just going to spitball. He's got a 50-50 chance.
Yeah, but you divide that by 6.02. So you're getting a number smaller than 0. No, that's not right.
10 to the first is 10. 1 power. So do this. Move this one over 1 place.
So you just get 7 points.
So, if you get 0,
You add 0.
You're to divide. Yeah, well, you don't have to type it. 'Cause when you divide, you subtract 10 to the 24th minus 10 to the 23rd. So you just move the decimal point over 1, like the 10th place. So you get 7.47.
is this like everyone? Oh,
Okay, so let's talk about some chemistry. My ceiling. I think I'm on. Did I just talk to Julie at that last problem?
I don't know.
Okay, I think I did. I think you have to pick what was the limiting factor. So we'll go talk to Mallory. Mallory, what am I going to do with 4.5 times 10 to the 24th? I like it. Matilda the Blonde, what does that give me? 0.75 times 10 to the first. 10 to the first is 10 times 0.75 is. Let's just go with that. I mean, I like to look sciencey too, but we don't always need scientific notation. Okay, so 7.5-ish moles of sodium. Nathan Parker, what am I going to do with 63 liters of oxygen? And what do I get when I do that, Elliot? What is 63 divided by 22.4? Say again? 2.8 moles of oxygen. Leo Falvo, what time is it now? It's stoichiometry time. Okay, so what, Leo, is going to go in my first ratio here? How much give me a chemical to start? Give me an anchor. Na2O goes where? Top or bottom? Na2O goes to the top, and its coefficient is? What goes to the bottom? Nope, look what row I'm in here. I'm working with sodium, so sodium's going to go to the bottom. What's sodium's coefficient? 4. Okay, Bridget, what's 7.5 times 2 over 4? 3.8 is my predicted moles there. Carly, what's my stoichiometric ratio going to be down here? Carlos, what does your calculator say 2.8 times 2 over 1 is? 2.8 times 2 over 1.
5.6.
Correct. 5.6 moles is what that would predict. Elsa, how many moles am I actually going to be able to make? 3.75, 3.8. This is my actual amount I'm going to make. What is my limiting factor here, Kaya? Na. Na is the limiting reactant. Nathan's guess was wrong. Right? I mean, good job. It goes for you. It doesn't matter. We're just guessing. Okay, so this you would not get full push credit if you just wrote like oxygen. Like you need to show some supporting work to get credit for this problem. Smiling on. I'm going to take all the molar conversion parts out of this and just address one last question with these problems. Okay, write down this confusing reaction. 3Na2S plus 2AlCl3 makes 6 salt and 2 aluminum sulfide. Write all that gobbledygook down. Go. MK, we are already in moles here. So what time is it?
Stoichiometry.
It's stoichiometry time. So I'm going to do some stoichiometry. Elizabeth, what chemical am I going to put in the denominator here? So it's Na2S, and there's 3 of them. Okay. And I'm going to put Al2S3 in the numerator here. And then I'm going to turn to my friend Ella and say, what am I going to put in the denominator here? 2 AlCl3. This class has this groove where you guys all like to put the number in first. That's fine. And I'll say 6 NaCl here. And what's wrong with this picture? This is going to lead you astray. Okay? This is going to crash you into rocks, my friends. Why is this not a good way to set up this problem? What am I solving for in the top one? What am I solving for in the bottom one? And that's not a fair comparison. Okay? You need to pick one chemical and use it in both of your numerators. So when we do this, if I pick Al2S3 up here, I need to use Al2S3 down here as well, so that I'm not cheating and giving this one, like this is getting multiplied by 6. That's a big advantage. Like that's going to give you a lot more moles of product to multiply by 6 compared to multiplying by 1. So it doesn't actually really matter which one you pick. Whichever one you pick, you want to use in both of your numerators. So let's write down consistent numerators. You want to have consistent stuff up in your numerator. Smile and nod. I'm going to hand out a homework and we're going to decide which one we want to put in the numerator once we take a look at this. Take one pass back. Take one chance to go behind you. Here you go. Take that up past the plate. Make sure that it's already got it. All right, in problem number 1, on the front of the page, we have 2 products. We have Na2SO3 and we have AlOH3. This is an example where you have to pick one of those products to put in your numerator. Looking at the whole sheet, looking at parts B, C, and D, which chemical do we probably want to put in our numerator? Na2SO3, because that's the one they're going to ask us about later on. So you could do the linear reagent problem with aluminum hydroxide in the numerator, but I would recommend, my free tip to you, use the one that you're going to need to get questions about, that you're going to get questions about later on in the problem. Have a great lunch experience. We have a test coming on Monday.